All right, here we go, number 11. So similar, this is another one where we've got elastic potential energy. The big difference is this. In the problem we just did, our thing started at a height of 0, and then we launched it up, right? Oh my gosh, that actually fired pretty hard. So we started at a height of 0, right? So in that one, all of our initial... I wasn't trying to shoot that. In that one, all of our initial energy was EPE, right? Okay? In number 11, what's happening is we're firing it off of a cliff. So, what kinds of energy do we have at the beginning, you guys? GPE and EPE, right? This thing's stretched, so it's got elastic potential energy, and it's got height, so it's got GPE, right? And then we're firing it from there. Follow? Okay, so your drawing should look like this. Oh, did I start? Oh, I did. Good. All right, so here we go. So this is number 11 on the review. So, I don't know. I mean, I guess you can picture a little slingshot, right? Initially, the slingshot is stretched back, so that's my point A. Then there's a point B, where the rock is just leaving the slingshot. And then it goes flying through the air, lands on the ground over here at point C, where it hits the ground. Make sense? So, with that in mind, here we go. At point A, I know my height is 30 meters. I know the mass of the stone was, is it 0.75 kilograms again, I think? And I know that we stretched the slingshot back 0.6 meters, because it's 60 centimeters, right? So you got to convert. Okay, but the problem is I don't know what my K is, so I can't actually find my elastic potential energy, right? Good? All right, over here at point B, I know my height is, at point B, remember B is up here. What's the height, you guys? Still 30, right? Mass is still the same. Wait a minute, what am I doing? Oh, what did I skip here? I skipped an important thing at point A. What did I forget? Velocity. What is it? 0. That's super huge. Everybody good? All right, and the mass is constant, so I don't know why I wrote that there. I guess it doesn't matter, whatever. Okay, so we don't know the velocity at point B, do we? What's x at point B? 0, right? Because that's the point where the rock is leaving the slingshot, so it's not stretched anymore. Cool? All right, but I can't find my total energy here because I don't know my velocity, so we're kind of stuck at point B. So let's think about point C. So at point C, the problem tells us the rock hits the ground with a velocity of 34 meters a second. What's the height at point C, you guys? 0. How much is the slingshot stretched at point 0, or at point C? 0. So which is the one point that'll allow me to find my total energy, you guys? Point C, right? Does it matter that I don't know K? What's the elastic potential energy at point C, you guys? 0, right? Okay, so to solve this, to find my K, I need to pick a point where I've got elastic potential energy, and I need to pick a point where I know the total. So, here we go. So the total energy at point A has got to equal the total energy at point C. So at point A, we've got elastic potential energy and gravitational potential energy. That's got to, at A, that's got to equal the kinetic energy at point C, right? You'd think I would move this thing that I keep tripping on every day for the last 12 weeks. Are we good? Okay, so let's see. We get 1/2 times K, which I don't know, times X, which is 0.6. Don't forget to square it. plus the mass of the rock times 9.8 times the height equals 1/2 the mass times the velocity. Don't forget to square it and solve for k. And it gives you, what is it, 1183? Is that right? Cool. Any problems, you guys? All right, and then you can find the velocity at point B kind of the same way, right? Set the total energy at C equal to the total energy at B. So total energy at B equals the total energy at C. So we're going to have 1/2 the mass times the velocity squared plus the mass times 9.8 times 30 equals 1/2 the mass times the velocity squared. And solve for V. There are other ways of doing it, if that works. Cool, you guys? Okay. Problem.